This video we will be looking at the properties of ROC. So the first property is ROC is a region or a strip parallel to j omega axis in S plane. So the ROC can be of the forms real S greater than A or real S less than A, or real S between minus A to A. These are the three forms of the ROCs. A is a real number. You know that in S plane, on x-axis there is sigma, which is real S, and on y-axis there is j omega. So this is S plane. Now what are the forms of ROC? ROC can be of the form real S greater than A, real S less than A, or real S between minus A to A. You know that if you are fixing the real S, that means sigma value, you are going to get one vertical line. If x is fixed, you are going to get a line. If we say in for the xy axis, if you fix here, if you fix x, this is x, this is y. If you fix x, that is x equal to 2 for example, then you will get the vertical line parallel to y axis. Similarly, in ROC, the real S is fixed. Real S means sigma is fixed. So for example, if sigma is equal to A, sigma is equal to A. So this is sigma is equal to A, this line. Now first ROC is real S greater than A. Then you will get the vertical lines parallel to j omega axis for real S or sigma value greater than A. This is the line for real S equal to A. That's why we say that ROC is a strip parallel to j omega axis. For example, if real S is less than A, then you will get the, this is real S is equal to A, then you will get the lines parallel to j omega axis up to infinity. Real S is less than A. Suppose real S is between minus A and A, then like this. So in short, we can say that ROC is nothing but the values of sigma. If sigma value is fixed, then you are definitely going to get one vertical line which is parallel to the j omega axis. Like if sigma equal to A, then you will get the line parallel to j omega, because j omega varies, and on j omega axis sigma is equal to 0. This is related with the graph, and you are well known with the graph that if x is fixed, then you will get the line parallel to the y-axis. Similarly, here real S is fixed, so we are getting the line parallel to the j omega axis. So this is the first point. Let us take the second point. ROC does not include any poles. You know that ROC is a region where excess, you are going to get the excess value finite, and we have already seen that at poles the excess value is infinite. That's why ROC does not include any poles. ROC is the region where you of convergence, or where the value is excess value is less than infinity. Here we have taken one example, x is equal to s plus 2 pole. Here s is equal to minus 2 is the pole. So s equal to minus 2 is the pole. So at s equal to minus 2, xs is equal to 1 by minus 2 plus 2, that is 1 by 0 equal to infinity. Xs is infinite at the pole, but ROC gives you the finite value. That's why it does not include any poles. Then, and I recommend you that you should first see the videos on the poles and zeros and the region of convergence of this channel. I will provide you the link, so you will get the better understanding. Now third point is, if xt is right sided signal, then ROC is a right sided of the form real S. Real S means sigma. Real S is in a previous video we have seen that S is equal to sigma plus j omega. Real S is sigma and imaginary S is j omega. So if xt is right sided, then ROC is also right sided of the form real S greater than A. So What is right sided signal? Right sided signal is nothing but it is the first point is that its duration is infinite. So here are two examples of right sided signal. Its duration is infinite, and the region before t naught in t naught region left to the t naught is equal to 0. Region left to the t naught is equal to 0 is the right sided signal. T naught can be positive or negative. So here t naught is negative, and here t naught is positive. So this is the right side definition of the right sided signal. So what we are saying, so first we have understood what is right sided signal. There is no relation between causality and right sided signal. Right sided signal, there are two conditions: duration is infinite and signal must be 0 towards left side of the t equal to t naught. Now they are saying that if it is a if your signal is right sided, then its ROC is also right sided, or it is given in the form real s greater than a. So take one example. Let us take the unit step. Let us find the Laplace transform of unit step. So this is the right sided signal because its duration is infinite and its value before t naught, here t naught equal to 0, at the left of t naught is equal to 0. That's why it is a right sided signal. So xs is equal to ut e raised to minus st dt, minus infinity to infinity. Now ut starts from 0 to infinity, so we have changed the limits 0 to infinity, then ut is equal to 1 e raised to minus st dt. Now the integration is e raised to minus st divided by minus s 0 to infinity. So minus 1 by s we have taken outside, and we have placed the limits e raised to minus s into infinity minus e raised to minus s into 0. So minus 1 by s e raised to minus s into infinity minus e raised to minus s into 0 is equal to 1. This is equal to 1. So now here the part of ROC comes. So we want e raised to minus s into infinity equal to 0. For that we want e raised to s into infinity equal to e raised to minus infinity, because e raised to minus infinity is equal to 0. Now how you will get that e raised to minus infinity? When s is positive, then only you will get here you will get e raised to minus s into infinity is equal to e raised to minus infinity. That means s should be positive, then only you will get e raised to minus infinity. So that is the ROC, real s greater than 0. Real s is greater than 0. If s is negative, then you will get e raised to s is negative, then negative s is negative into infinity, that is equal to positive infinity, that is equal to e raised to infinity, and e raised to infinity is equal to, here it is e raised to infinity is equal to infinity. Here I have written it. So e raised to infinity is equal to infinity. So to have the convergence, you need real s greater than 0. That means keep in mind that you want e raised to minus infinity. Accordingly ROC comes, and then only you will get 0 value, otherwise you will get e raised to infinity is equal to infinite. So e raised to minus infinity is equal to 0, and e raised to infinity equal to infinity. Okay, so ROC, what you get? ROC is real s greater than 0. So ROC is real s greater than 0. ROC we are plotting it on the S plane, where here it is sigma, j omega, and ROC is real s greater than 0, vertical lines greater than 0, sigma equal to 0. So ROC is also right sided. Then next point, if xt is left sided signal, ROC is left sided in the form of real s less than a. Okay, so left sided signal is it's having duration infinity, and its value towards the right of t equal to t naught, towards right of t equal to t naught equal to 0. So that is left sided signal. T naught can be positive or negative. Now let us take one example, u of minus t. So let us take the Laplace transform of u of minus t. So this is left sided signal. xs is equal to minus infinity to infinity xt e raised to minus st dt. So that is equal to minus infinity to 0. Limits are minus infinity to 0, minus infinity to 0. Ut is equal to u of minus t is equal to 1, because xt is u of minus t. E raised to minus st dt. So that is integration is e raised to minus st divided by s, minus 1 by s, and limits are minus infinity to 0. So next, minus 1 by s, e raised to minus s into 0 minus e raised to minus into minus infinity. So we have just put the limits. So minus 1 by s, this is e raised to 0 is 1, and then e raised to minus s into minus infinity is s, e raised to s into infinity. Now what we have just previously seen, that we want here e raised to minus infinity. For that, s should be less than 0. So real s should be less than 0. That then only we will get e raised to minus infinity equal to 0. Otherwise, e raised to plus infinity is the plus value is there, you will get s. E raised to s into infinity is e raised to infinity. S can be 1, 2, 3, 4, anything. I have not written it because multiplying 1 into infinity is infinity only. So ROC is real s less than 0. Now ROC is plotted on the S-plane, where on x-axis there is sigma, on y-axis there is j omega, and real S means sigma is greater than 0, sigma is equal to 0 is j omega axis, sigma is less than 0 means these lines. So ROC is also left sided. One simple point I am going to tell you here, that if s equal to sigma plus j omega, and then you will get point. This is simple. And if s equal to sigma, then you will get, or if sigma equal to anything a, then you will get one line. That's why in all the first point comes that ROC is nothing but the vertical lines parallel to the j omega axis. Fifth and final point is, for both sided signal, ROC have the form minus a less than real s less than a. Here one thing you keep in mind, that ROC can exist for the both sided signal or it cannot exist. If it exists, then it has the form between minus a less than real s less than a. That means between 2 points you will get the ROC. So both side, this is both sided signal. Again, both sided signal is having the duration infinite. So how this signal is formed, you know, this is your e raised to 80 minus 80. If here we are taking e raised to minus 2t. If e raised to minus 2t is multiplied by with ut, you will get this portion. Now this is what? This is e raised to 2t. If e raised to 2t is multiplied with u minus t, this part will be cancelled and you will get only this part. Okay. So when we solve the problems, we will go in deep of all these problems. But here only listing the properties, I feel will not be that much informative, rather than including one problem. If we include one example, then it will be easy for you to remember those properties. So this is the both sided signal. So e raised to minus 2t ut plus e raised to 2t u of minus t. Now excess of this e raised to minus 2t ut, its excess is 1 by s plus 2. So I am not going to solve this problem. This is the simple formula. We can remember this formula, and when we are going to find the Laplace transform of exponential, there we will explain this how the value of x is equal to 1 by s plus 2. But for this video, we are just going to write it down, and it is very easy to write. So if it is minus 2, you have to take 1 by s plus 2, and plus e raised to 2t u of minus t minus 1 by, so here it is 2 is there, so it is s minus 2. These are standard results. When we solve it, you will come to know that these are the standard results of the Laplace transform. So this is your Laplace transform of e raised to minus 2t ut, and this is Laplace transform of e raised to 2t u of minus t. Now in this case we should see towards the ROC of e raised to minus 2t ut. ROC of this is real s greater than minus 2. Real s, this is also a standard result. Then e raised to 2t u of minus t, its Laplace transform is minus 1 by s minus 2, and its ROC is real s is less than 2. Now if we plot this ROC, real s is less than 2 is this ROC, okay, and real s is greater than minus 2 is this ROC. Now the intersection between these two comes here only, that is minus 2 to 2. So for both sided signal, the ROC is intersection between two individual ROCs. So intersection comes in between minus 2 to 2. So its ROC, both sided signals xt's ROC is minus 2 less than real s less than 2. Okay, so for both sided signal, if ROC exists, then it is in the form minus a less than real s less than a. For both sided signal, we have to individually see the ROCs of each signal, then see the intersection between the ROCs and take that intersection as the ROC of the both sided signal. So this is standard result. E raised to minus 2t ut is 1 by s plus 2, and ut is there, so real s greater than minus 2. E raised to 2t u of minus t is minus 1 by s minus 2, and real s u of minus t is there, so real s less than 2. When we solve the exponential Laplace transform of exponential in the next videos, there we will get more understanding about how these results come and how to remember these results. Okay, so these are the properties of ROC. I have tried to include the examples instead of just listing the properties, and tried to explain you with the examples. I hope this will be this you all have understood this. So in next videos, so for this video, first you have to see two videos that I will give you in the description box. So first see those videos, after that see this video, and after these we are going to solve Laplace transforms for some standard signals. Okay, so that's it for this video. Thank you.